Hello class, today's video is going to be really brief because it's a review of some concepts that we learned in middle school. One such concept is on triangles. And so if you remember, a triangle is a polygon with three sides, and a triangle has two types of angles: interior angles and opposite angles. And so the definition may be a little bit difficult, but actually interior angles are the angles that are in between or inside a triangle. So these are all interior angles. And a little bit later on, we're going to talk about exterior angles. So we're going to come back to that. So here we have a way to classify triangles. Two ways to classify triangles: by sides, the relationship of their sides, and by their angles. So you guys may remember the names of these different types of triangles: scalene, isosceles, equilateral. That's classifying it by its sides. An equilateral triangle has exactly three sides that are congruent, and we mean by the same length. And if you look at this picture, you know that these sides are congruent because they have the same markings to indicate that they each measure the same length as each other. So in an equilateral triangle, we have three congruent sides. In an isosceles triangle, some books say you have at least two congruent sides, or some books say you have exactly two congruent sides. But as we can see here, we have these two sides which are congruent, and we know they're congruent because they both have the same mark to indicate that they're the same length. And then the last type of triangle is a scalene triangle, and it's a scalene triangle because it has no congruent sides. As you can see, no markings to indicate none of these sides are congruent. Now, a great thing about knowing that the relationship between the sides, we also know some information about the relationship between the angles. And the relationship there is that if an equilateral triangle has three congruent sides, then it also has three congruent angles. So as we can see here, because it has three pairs of congruent sides, it also has three pairs of congruent angles. And that's just something that's normal for an equilateral triangle only. But an isosceles triangle, since two opposite sides are congruent, then that means it not only has two pairs of opposites, two sides that are congruent, it also has two angles that are congruent. And because we have here a scalene triangle, it means here that no congruent sides or angles. Okay? Moving on, and you can find this chart on page 85 in the note-taking guide. Moving on, let's try and classify triangles by their angles. An acute triangle is a triangle that has all acute angles. So there are three acute angles. A right triangle has exactly one right angle. An obtuse triangle has also exactly not one right but one obtuse angle. And an equiangular triangle has all three angles that are congruent, and you can see that because each angle has the same marking for its mark. Well, how many right angles can a right triangle have? Well, if you said exactly one, you're absolutely correct, and the same for obtuse. And the reason being is an obtuse can only have one obtuse angle, and a right triangle can only have one right angle, is because the sum of the measures of the interior angles of a triangle is 180 degrees. And you guys know that from middle school, that if I add up all the interior angles of a triangle, I get 180 degrees. So if I have a right angle, that's going to be at least 90 degrees, which means that the other two angles will have to add up to 9 degrees in order to make 180. So that means you can't have more than one right angle, because if you have two right angles, then two of the angles would be 90 degrees each, which make it 180, which would be far larger than the number that's required. So the sum of the angles of any triangle are always going to add up to 180 on a flat surface. Now, there are triangles that there's some angle measurements do not add up to 180, but that's on a surface, like a circular surface, but spherical surface. But we're not going to talk about that. Anyway, but today we want to talk about this important exterior angle theorem. And so remember, I talked about earlier, I mentioned that there's interior angles. Well, here's an example of an interior angle, as we see here. But the exterior angle is the angle that's adjacent to an interior angle, and it shares a side with the interior angle. And as you can see, we have a linear pair between this interior angle at C and this exterior angle. And because it isn't a linear pair, then one thing that we do know, because we have a linear pair, is that if I add up the measure of the interior and the exterior angle, I should also get 180 degrees. Why is that important? Well, I also know that if I add up A and B and C, I also get 180 degrees. So that produces a relationship between A, B, and the exterior angle that it doesn't include, which means they both are equal to the difference between 180 and C. So since the interior angle C and the exterior angle 1 are supplemented, are either a linear pair and adjacent and add up to 180, then that means a way you can calculate the measure of angle 1 is 180 minus the measure of angle C. But another thing to note is that also the A plus B plus C adds up to 180. So if I want to figure out what the sum is of A and B, I just do the same thing by saying the measure of A and B is equal to 180 minus C. Well, since both of these things are equal to 180 minus C, then I have a way to come up with another equation, which says the measure of the exterior angle of C is equal to the sum of the measures of angles A and B, as you can see here. And we call that the exterior angle theorem.